Okay guys, today we are going to talk about the area between curves and the way that you evaluate the area between curves using integration. Let's say we have two functions. Say f of x looks like this. And let's say that g of x is graphed in the same coordinate plane, and we wanted to find the area that is between these two graphs. This area here. If we wanted to find this area, there's a formula or a theorem that says the area between two curves is the integral of the greater function minus the integral of the lesser function over the given interval. So our given interval here is from the two intersection points. Our two intersection points, it intersects here and also here. Now I drew a line down to the x-axis because that's going to be our limits of integration. Let's call them A and B. These are the x values in which these two functions intersect. So if we want this total area, so if this area is what we were looking for, we would find the intersection points, A and B. Those would be the x values where these two graphs intersect. And since g of x is always greater than f of x over the interval a to b, then we would take the integral from a to b of g of x, the greater function, minus f of x, the lesser function, over that interval. And that would give us our area. So let's take a look at a problem. So if we needed to find the area between this graph and the x-axis, what we would do is you would have to integrate to find the lower area. Now, since it's below the x-axis, when you integrate, you're going to get a negative value from -2 to 0. And then from 0 to 2, when you integrate, it's above the x-axis, so you're going to get a positive value. So we want to integrate from -2 to 0, and then we want to integrate from 0 to 2. When we integrate from -2 to 0, you need to make that the opposite of the integral from -2 to 0. So we have two integrals. This first integral here, the negative integral from -2 to 0, that is going to give us this area. The other integral is going to give us our other area. So we just have to take these two areas and add them up. Now, when you integrate, this is going to have to be a U-substitution integration. This is what we start with. I'm going to allow my u to be 4 minus x squared my du is -2x dx. Substitute in. And I moved my x out to the right. Now I need to balance by a factor of -2. So if I put -2 in, you have to balance out front by negative 1/2. So I have the integral negative 1/2 times negative integral. Negative times negative is positive. So that's positive 1/2 out front. The integral from negative 2 to 0, u to the 1/2, and then negative 2x dx, well, that's the same as du, so I can go ahead and put du there. So now I'm ready to evaluate my integral. Okay, at this point, you need to, at this point, we can't go any farther unless we change u back to 4 minus x squared. Or, if we change our limits are, we integrated in terms of u's. So if we change our limits, negative 2 and 0, if we plug that in for x, we let u equal 4 minus x squared. U equals 4 minus x squared. So if we plug these values in, 0 for x, we get 4. If we plug in negative 2 for x, we get 0. So we can either integrate in terms of u's or change back to x's. You change back to x's by plugging 4 minus x squared in for the u variable. So I've changed my limits now. Instead of negative 2 and 0, I'm going to use 0 and 4. This is in terms of u's. And 1/3 4 to the 3/2 minus 1/3 0 to the 3/2. The back part of this, the second term, is going to be 0. But the first term, 4 raised to the 3/2 power, is going to be, well, 4 to the 3rd is 64. And then you take the square root of that is 8. So it's 1/3 times 8. And that gives you 8/3. Remember, this is the piece that whenever we were looking at the graph, we found the area of this piece by looking at the graph. Now we need to find the area of the other piece. This area is what we still need. So let's put that 8/3 to the side for a minute and see what the area from 0 to 2 is of the same function. So we set it up U-substitution. Same U, same du. Balancing. So here's what we need to integrate. When you integrate, you can go ahead and change the limits now. Instead of 0 and 2, if you plug 0 in for x, u equals 4 minus x squared. So then u would equal 4 minus 0 squared, which is just 4. So it would be from 4 up to 0. And when you actually perform the integration, you're going to have a negative and a negative, which makes it a positive. And it's going to end up as 8/3. Same limits as we just had. Now, if you're integrating from 4 to 0, that's the same as the opposite of the integral from 0 to 4. So we can take care of that negative now, or we can just take care of it whenever it comes up when we perform the integration. So I'll just take care of it whenever we perform the integration. So whenever I anti-differentiate, I'm going to start a new slide. This is what you get whenever you anti-differentiate, and then now evaluating it at those limits. So it's negative 1/3 a few calculations, we get that this area is also 8/3. So we have 8/3 on the left-hand side of the y-axis. We have 8/3 on the right-hand side of the y-axis. So the total area between the curves is going to be 16/3. (16/3 units squared). Okay, here's another problem where we're trying to find the area between y equals x squared and y equals negative x squared plus 4x. So what we have is we have a parabola opening up, we have a parabola opening down. There's going to be area between curves. If you have your a graphing utility, TI-84, or some other handheld graphing calculator, or if you have graphing software, you can take a look at what these curves look like. What we need to do is we need to find when these two curves intersect, and we need to determine which function is greater over that given interval, and then we can use our formula where we integrate over the intersection points. So first of all, what this looks like is this is what these two functions look like. You have y equals x squared in yellow, y equals negative x squared plus 4x in red. And what we're looking for is we're looking for the area between the graphs. This area here. So we need to find out where these two curves intersect. So they're both solved for y. Set them equal, and solve for x. So I've set them equal. Take that negative x squared to the left and the 4x to the left. You get 2x squared minus 4x equals 0. Factor out a 2x. You have 2x times x minus 2 equals 0. And then now use the zero product property. So 2x equals 0, x minus 2 equals 0. So here are our coordinates, or they're not coordinates, they're just the x values where these two intersect. We could find the y values, but we don't need to. So we're going to integrate from 0 to 2, and the greater function is the one in red. So the greater function is negative x squared plus 4x. So we take that one and we subtract x squared. That's the lesser function. And we evaluate this integral from 0 to 2. This is what we simplify to, and then evaluate, anti-differentiate. So when you anti-differentiate, this is what you get when you anti-differentiate. So evaluate this at 2, and then subtract, evaluate this at 0. When we evaluate at 0, the answer is 0. When you plug 0 in for x, you get 0. So this is our evaluation, and what you get is going to be negative 16/3 plus 8. Negative 16/3 plus 8 is 8/3. So you get 8/3 units squared. Okay, whenever you're integrating with respect to y, it's the same. You integrate over the interval, but now we're integrating up and down, or down to up, I suppose. Here, these two graphs intersect at 0 and 1. The graph in red is x equals 2y squared minus 2y. The graph in white is x equals 12y squared minus 12y to the third. So, to find which one's greater, you need to look which one is farthest to the right over the interval y equals 0 to y equals 1. So from 0 to 1, remember we're looking down and up. From 0 to 1, which one is greater means which one is farther to the right. That would be the graph that's in white is always the greater one. So here you would want to integrate from 0 to 1 of the graph in white minus the graph in red. This is our integral. Now there's some cleaning up to do, some combining of like terms. I'll go ahead and do that. and then you integrate from 0 to 1. So when you anti-differentiate, you get negative 3y to the 4 plus 10 thirds y to the third plus y squared, evaluated from 0 to 1. When you plug in 1, you get 4 thirds. When you plug in 0, you get 0. So our answer here is 4 thirds. And of course, it's always units squared. I hope this has helped. And good luck with finding areas between graphs.